Hey, welcome to another coding session. Back with Bangalang, as always. Continuing through these features, which, okay, modules is a feature, but these two here are kind of more like fixing bugs or problems with the language. This is the one I want to tackle today. So I want to be able to index with any int type. Right now, if we look at our source code, where we do some indexing, where's some offensive code? Here we go. This kind of thing. I've got this info log length, which is an I32, and I'm having to cast it to an I64, convert it to an I64 just to index, which I think is not very nice. So I prefer that we can do like this. And once we've got that figured out, the other thing I would like to do is actually be able to omit this, and it will assume the start. And if you omit this, it will assume the end. So this would be a slice of the whole array. So I think we have also here, let me find if there's anywhere else we have to cast to I64. Doesn't look like it. So I guess that's probably the only two places. All right, so let's figure out what we need to do to fix that. I think kind of the main thing is that I need to introduce kind of an any int type. Right now we have a number type that we use in a lot of places. I think I'm going to change that to any number. If I do that, and let's see where we have changed it. And then we're going to introduce the idea of any float and any int. So that's a bit narrower than any number. Any number could be a float or an int. So to get a couple of examples of this. So this is where we have a number literal, and we're trying to assign a type to it. So I think what I'm going to do is say that if, I think it's contains, strings dot contains. So if the literal, this is the actual value, contains a period, then we're going to say it's any float, because that's a bit narrower, right? If there's a decimal in the number, that means it can only be used as a float. But if there's not a decimal, it could be used as anything. It could be used as a float or as an int. We don't know yet. We could use it as anything. So that's the first thing. So that's where we have any float. The other place where we really want to change something, and this is the main motivation here, is when we're indexing. This is where we type check our indexes, and at the moment you can see we're checking against I64. So we're forcing it to be I64. So instead of that, what I want to do is create a type node, an any int type node, and I want to type check against that. So then anything that satisfies any int will pass type checking. Then, because what we type checking against might just be a number literal, where was it? Like this, which means it might just be any number. If it was a float, then it would fail the type checking at that point. But if it was any number, it would succeed. It would get upgraded, I believe, to any int. It depends how we do the type coercion. I think maybe it would just be stay as any int, or any number. I'm not sure. But in any case, we can't use an any int or an any number when we go to generation. We have to have a concrete type. So I'm going to say upgrade types of this node, and then I'm going to say I64. So what that does is, if after this type checking we don't have a concrete type for our expression yet, then we're going to assign we're going to use I64 as the type. So now I64 is more of a backup. If we don't find a concrete type, then we use I64, but we're not enforcing I64 anymore. So this is the main thing we want to do. Now I want to go through anywhere where we have changes, because we changed this type, and see if there's anything else we need to change. Like, for example, here, this is in the test suite, and we can't write tests that are for types which are not concrete types. So we want to ignore all three of those. And there's another one down here. So we ignore all of those. Now in type checking, what do we have up here? In numeric types, we have any number. So actually, any float and any int are also valid numbers. Here we can only put any float. And I also want to introduce a new one, which is all integers. So that would have any int. Would it also? No, it shouldn't have any number. And it should not have these floating point numbers here. So this has anything including all of the incomplete types. This is all the floats including the incomplete one, all the integers including the incomplete one. Good. Here we're saying, we're complaining that we didn't get a complete type. So these are also not complete types. This is interesting. So here, this is where we have something like x equals 4 is less than 5. So in this case, there's no type information here or here. We do know that this is going to be a bool because less than produces a bool. And we don't know what these numbers should be. So if we received any number, we should, well, if we received any float, because the reason we would get this situation is only because we have number literals. And like we did before down here, we said number literals can be any number or any float. So if we got any float, we'll upgrade them to F64. If we got any number, that means that it's not a float. So let's use I64 instead. And we don't need to do any int in here because it's not possible for it to occur here. This is the code that we changed just before. So is this, that one's all good. Here's type coercion. So we're checking any number. We also need to do any float. So this is the same thing, but we check only against float types. And also integers. So basically in type coercion, what all these are saying is that if one of the types is any number and the other one is anything numerical, or is not something numerical, then we've got a mismatch, right? Or if we find it any float and the other one is not a float type, then we've got a mismatch. So that's why we're saying we fail. The types are not compatible. A and B. And then down here, it's I think this is kind of saying like if we didn't come across any of these any types, then we should also fail. So I think we need to add these guys in here. And another thing is that if we didn't fail, we have an any number and we didn't fail, then we shouldn't fail due to these. Because if we have any float here and this one is, and A was an any number, then this would fail. But we've already established that they're all good here. So we kind of need to say like if we're not dealing with any numbers, then we want to do these extra checks. I think that's the idea. And also down here, we can say like any float or any int. So I guess the idea is that we want to upgrade, right? If we find one of these any's in A, then we use B. So we would use potentially a more concrete type. But if B was a number, any number, then we would be downgrading effectively, becoming less narrow in our types. So I think what we need to do is say like before this, say if A is any number, if A is any number, then return B. If B is any number, return A. So we're always upgrading from any number, if we can. And if neither of them was any number, then we need to upgrade from one of these to something else. I think that makes sense. And then the last change down here is, this is upgrade types. So this is used in a few places. We just used it here. So basically we need to include all of our incomplete types here, so that when we're doing an upgrade, it will upgrade them. Cool. So I think that's all the type checking sorted. That seems to be the only place where we have changes. These are the changes we manually did. So it should pass type checking. Now we have generation. And the only thing that should be different here is our indexing. I think this is indexing. Here we go. Because this location here now could be pointing at different sized integers. But when we use it, like this comparison here against a length, that is a 64-bit number. Potentially, it might be an immediate or something, but it could potentially be the memory location of a 64-bit number. So this really should be a 64-bit number as well. Same with this offsetting here. We're using it as an offset of an address, and address is a 64-bit number. So when we add to it, that also needs to be a 64-bit. So what I'm trying to get at here is we need to make sure that this is a 64-bit number. So I think we need to move this back up here, and then also do a conversion to a 64-bit. So we do have some conversion code, remember, that we added recently. Here it is. No, that's not it. Here it is. So I think we need to extract this. I'm not sure how much to extract. Like so. This is more like it's more like source and dest. But I'll create parameters with those names at first, so I can do some copy and replace. Source type node, dest type node, these are all source, and these are all dest. Source. Okay, so source and destination, we're doing all these different conversions. The tricky kind of bit is here because we're assuming that the source and destination register are the same register, which I kind of don't like, but I think we can get away with it still. So we kind of want to go from a, I guess we need the file as well, right? We kind of want to go from a source location to a register. And we'll return a location. So if the types are the same, we just return the parameter location. There's nothing to do. Cool. And we create a destination location, which is a register, which we use in all cases except for this one, where we just say leave it in the source location. So yeah, that's why the source location, yeah. So if it is a register, we're just going to return this, which is assuming that the source was also this register number. So that's what I don't like so much, and it's a bit tricky to verify that this is that number. So we're going to leave it for now, but I just, yeah, I'm not a big fan. Okay, so let's return convert file, param location, register num, param type node, return type node. I think that's it. Okay, but we have a bunch of errors. What are they? I should have done a proper rename of that. Okay, so now up here we're able to convert, right? We're converting this to this register number. Yep, that's correct. And this was the type, and we want to convert it to an I64. So I'm just going to create an I64 type node, AST node, so that I can put it in there. That's what the type, we're converting it to an I64. Cool. So that makes sure it's an I64. And we have the same thing for end expression. So let's just do, was it convert to index type node. Cool. Okay, so hopefully that conversion should take care of it. So then this should work. Ah, we have tests turned on. So I guess we're verifying the tests while we're at it. If the tests are passing so far, I guess that's a good sign. Hey, there we go. It worked. Yeah, you can see on the test that we index with just literals as well. So we got this working. That's pretty sweet. Now I want to cut this out. So if we look for this in the source code, I'm just trying to see where all the places are that we could get rid of it. Start, end, that will need both of them. Here we go. 0 length. It does need the length because we're kind of truncating it, but it doesn't need the 0 at the start. These are just regular indexes. Here we go. So this one has 0, and then it also has string buff.length, which is this variable here. So I think we can just take this out. So this is basically taking this string buff array and converting it to a slice, because this procedure wants a slice. And then there's these ones that we already know about. Cool. So we're going to have to make a bit of a grammar change for this one. With our indexing, where is our indexing? Oh, it's here. So I think the easiest way, because these can be optional now, but if you're just doing a single, like you can't just have these brackets empty, there's got to be something in there. So I think I'm just going to split it into 2 different options. So let's say in brackets that, or so it's either a right-hand side expression or this. So typically I don't think I would put brackets around that like that. So it's either this or this. I think that should be clear because we have brackets around the whole thing. And if we have expression colon expression, both of those expressions are optional. So let's have a look and see if that makes sense. So within our brackets, we have either a right-hand side expression or optional right-hand expression colon optional expression. Looks good to me. So we're going to have to modify our parsing to handle that. So square brackets, this is it here. We're not talking about types because that's when we're giving arrays lengths and things. So we're here. So the start expression node is optional. So if we have a colon at the start, then we need to put something else in. And I think what I'm going to put is a null node. probably could just do that, right? I think we need to have, yeah. Just put a nil node just to say we're not putting anything here. So at the start, we can either have a nil or a start expression. And for this case here, where it's just a right-hand side expression, that means that there definitely won't be a colon. So we're still doing this. So I think that handles that case properly. Then if we do find a colon, then after it, we're going to do something very similar. But this time with closing square bracket. So after the colon, if there's a closing square bracket, we just put a nil node in, otherwise we'll put the expression in. So I think that should handle parsing. Type checking, I don't think we actually need to change anything in type checking. I don't think. I think it's more generation. Let's see, we might have to go back. But in generation, our start expression node, so this could be a nil node. If the type equals nil, then our location becomes immediate 0. I'm going to put that up there. So maybe I'll actually put that there, and do we need it to be in a register and everything? Yeah, I think we do. So I think we need to keep that as a common thing. That's needed here. So we copy it to a register. Yeah, okay, I think that's the safest thing to do. If it's not a null, then we need to generate an expression from the node. Okay. And then I guess we need to do something similar for the end location here. So this is the end expression location. So actually we should probably put that there. But we don't want immediate 0 now. We actually want the length location. I'm going to rename this to child length location so it's a bit clearer. So it's the length of the thing we're indexing into, which should be the default at the end. So put that here. And then if there is an expression, we override it. I think that should work. Hey, oh dear. Okay. So it looks like we do have an issue there. So what has happened? This is in the I2A. So if we fix that one up, yeah, now we get proper FPS. So this 0 doesn't seem to be working properly, emitting this 0. Which is interesting because nothing else seemed to, well, I think everywhere else is just like, it's just like error handling, so it's not actually getting triggered. Well, this is. So that, interestingly, that worked. Huh. But this did not. That's really weird. Okay, so let's go back to generation and go back to the start. So if the start expression location, the start expression node is not a nil node, we generate the expression and from there do everything. But if it is a nil node, we have an immediate 0, which we copy into a register, and then we convert to the right size. Which might be a bit more work than we really need to do for an immediate, but it should work. I don't see that there would be any problem. So maybe we can have a look at, it seems like the end of I2A is an issue. Well, let's just verify that it still is an issue. Yeah. So if we have a look at the I2A code, I2A assembly, go to the bottom. That's the end, close expression. So this is the return here. Well, actually down to like here. So it's quite a lot, but we should find that the start is 0. And where will that actually show up in the assembly? Start expression location. So it's always going to be, so we should see a copy of 0 to a register. That reminds me, I want to do something like this in these other copies. So that it's clearer what the reason is for doing some of these copies. So now if we go here, okay. So yeah, we have copy 0 into a register. We compare 0 to some variable. We compare it to 0, which is kind of pointless. Then we copy another value to a register. We copy the 0 into here to do an offset, so that's not going to need to offset either. So that all looks good. Sub RSP16. So now we allocate, we're allocating the slice, I guess. So first we're putting R11, which is our address. That makes sense. And then RSP plus 8 should contain, that's interesting, move to a register and then compare with itself. Yeah, I guess that makes sense actually. We put in the length in there and then we're doing bounce checking on the length, which is kind of pointless. Yeah, so I guess that is a point. We're doing some pointless bounce checking now. If that's nil, we know that it's not out of bounds. Oh, that could be an issue. That's why it worked when both of them were nil, but not one of them. Yeah, okay. So let's not make that copy past error twice, but let's avoid some bounce checking. We don't need it. There we go. Yeah, so now it's working. And if we go to the assembly, we should see, yeah, there's a lot less bounce checking. There's still bounce checking here, even though it looks to me like it shouldn't need to. So let's have a look. Ooh. Or both of those mean you don't need to bounce check. Okay, let's have a look again. I do still see a bunch of bounce checking, but this one looks kind of legit because they're different locations. Copy 0 to register. Compare with the length. Why are these different now? Oh, they should be different actually. So that's legit. There should be bounce checking there. There should not be bounce checking here. I don't really see a reason for that. If we know that we're going to 0, so if it equals 0, so these conditions were just like totally wrong. Okay. But I still see the bounce checking. This one is legit. This one is pointless. Oh no, I'm getting so confused with these conditions. So if it's not nil and it's not boundless, then we bounce check. Okay, Jesus. Don't know why I'm getting so confused here. Let's try that again. Okay, it seems happy. No, I mean the frame rate's pretty bad, but yeah, so we have no bounce checking up here now, but we do have it here because it's still needed. Okay, that's better. Cool. And I guess technically you wouldn't need this negative slice length either, because with the bounce checking, we've established that they're both like that. This, we know this is 0, and we know this is at least 0 or more because of the bounce checking. So we know that there's not a negative length of the slice. You know, that's something that would occur if you had like 5, 3. That doesn't make sense. That's the negative length. Cool. So we actually powered through that pretty quickly. That's both of these sorted. These two are kind of big, so I don't want to start them right now. But we could nail some of these things. This negative number literals is something I would like to do. If we go into the assembly and look for a neg, like, well, this, I think for the xad, it actually does kind of make sense. But here, so here we have a 1 literal that we're putting into a register, then negating, and then copying. So that's like a -1. This is in start thread. So if I go to start thread, it's probably this guy here. So I would prefer actually if we could just do this, you know. It might even collapse down to this. I think that would be better. We don't need to negate if we can just hardcode the negative number directly. And the way to do that is to improve our parsing. so that we can have negative numbers. Is it parsing? No, tokenization. We don't go in here very often. We have to be a bit careful because minus is a token of its own. And actually, the tokens are parsed before numbers are. So that would pick up the minus. So I don't think there will be danger in putting this down here. Maybe I'll just put it down below everything. If nothing else gets picks it up, then let's see if it's one of these fixed tokens. So now we're saying that the beginning of a number could be a minus. So we can have negative numbers. But if we just do it like that, it's going to take over, like we will never get this token because it'll always get processed by this thing here. So it's a bit ugly, but I think we're going to have to say like, it's got to be a minus followed by a number, which apparently we can't do. Plus offset, plus offset. Oh, equals. So now we can. So I think that should hopefully be all we need to do, and then negative numbers will be negative numbers. So it seems happy. And look, here we go. It did it. It did exactly what I hoped it would do. So that got rid of a couple of lines of assembly. Made things a bit simpler. Very nice. That is like a grammar change as well. Because a number can start with a minus now. Here's our minus. So start with a minus. There is something a little bit like, because generally when I have something in double quotes, I'm saying that it's an entire token, literal. So I think I might have like a single quote thing to say like this is just a character that is part of a token. Because when we say number, we're still like combining digits together, but they're not like a sequence of tokens, they're a sequence of characters. So, I mean, I'm making this syntax up as I go, kind of. There probably is some like quite standard way of doing it, but I'm just kind of making. I think when I investigated, I saw there was like just a whole bunch of ways of doing it. There's not like one standard, it seems like. So, just going to do this. Eventually, I should have like upper and lowercase letters represented in here. So these are all characters. I'm not sure why that had an extra double quote there. I think that makes more sense. So now we have like a double quote followed by not a double quote. That's my attempt at that. As many of you want not double quotes, followed by a double quote. And a C string is the same thing, prefixed with a C. I would actually like to, we have a bit of time left, so I think I would kind of like to combine these into one thing. I think it makes sense. Yeah. And here for a number, we can have optionally a negative character followed by one or more digits, followed by a period. So I have said you have to have a digit at the start. You can't just have a dot. Followed optionally by a dot and then 0 or more digits. Okay. So yeah, let's have a go at the C string because it's very related to what we're doing at the moment. I'm just going to do a whip commit for now, so I don't break anything too much. I can see what I've changed. So if we go down to, so basically I want to combine these literals. So this is no longer a thing. And instead we have like a any string type. So if we have a string literal, it becomes an any string. It might be a C string or a string. We don't know yet. I guess we have in here the C string business. We don't want a C string token type either. So let's pull that out. So that's probably going to be tokenization. We have to, where is our C string? Here, this is the one that starts with C. So we cut that out also. So this is always nice, cutting out code. Right, but now we're stuck with this any string. So we're going to have to do some type coercion. Where's our type coercion? Type name. Oh, that does remind me, in our types, instead of having like any float, which I don't think looks very nice, let's do something, not a whole lot different, but just something I think looks a bit nicer, like that. So any int and any number would do the same thing. And I guess also any string. Okay. So now if we run that, we'll probably get, oh, there's still C string stuff. Okay, here. So I guess here we need to say like something similar to what we do in here. Switch on the type. So if we find string, we do this. If we find C string, then we do this. And if we find neither, then we are somewhere that we should not be. Yeah. Missing return statement. Okay, we don't have a return outside. So I guess I just need to return something. Just return like an empty location. And C string is not a literal node type anymore. Okay, expected type comma, found type string. Well, that's interesting. So that's example line 40. It's because we have the C here. So anywhere in a Bang file that has C quote, we just need to change it to double quote. So the interesting thing here is that we don't give it any type information, right? This is any string, so this is any string. It's probably going to complain about that. Yeah, incompatible types. Because a string is actually a slice of I8s, so it's not the best error message right now. This should probably say string. But this procedure is expecting a string here. Why does it need to pass the length in as well? The string has the, because this is a C string. Was a C string. So really we should make this just a regular string and pass it in. Yeah, let's do that, eh? Compile shader. See, I was expecting a C string. Standard lib 8. Here. Yeah. So what I was thinking actually that we should do is have a default. So if we come across, we didn't do any type coercion, did we? In the end. It ran, so I assume that error is not actually an error. It's confused. Yeah, I think it's just confused. So if we go to, here we got distracted by naming. Here's our type coercion. So if we find any string and we'll say string types, which I guess we can put up here. So any string, C string, and string. I'm not sure if this is going to work actually because strings are just aliases of slices, so it might not work actually. But if we come across at any string and we can upgrade it to a string, yeah, this is actually a bit trickier because of that. Maybe where is it? We'll put string types. Maybe instead of that, we'll do something a bit more manual, at least for now, just to so it works. So if we come across in any string, we can check if A is a string. So A is a string if A.value equals slice and A.children, the first child, is I8, so it's a slice of I8s. And it's a C string if C string is still just C string. So if it's not either of those. And now we do with B. That should be, yeah, okay. Yeah, so that should, and then if we come across any string here, we take the other one. So that should solve quite a few places, I would expect. Maybe not. I thought this would get solved because I thought the type cohesion would then choose, okay, any string can be a slice of I8. Oh, another thing in here that we need to do is add these. If A is an any string, take B. And B should be, like in this situation, B is slice of I8. Do we ever get B string true? Any string, slice, I8. So B string true. Maybe this condition is wrong. Yeah. That should be ORed together. Yeah. Still an issue. So here we have B string true. So A value is any string. So we got that. And B is not a string and B is not an... No, I think it was right. Right? If A is an E string and B is not a string and B is not a C string, then we have a problem. If A is a string and B is a string, we don't have a problem. Yeah, I think that's right. Isn't it? So we're never going into these. So it's passing those. Oh, they have different lengths of children. That might be it. Yeah, because A is any string, B is a slice of I8s. So it has a child. Slice has a child. This does not. So it's the children thing. I'm just going to do this hacky thing where if we come into here and we get past all this stuff, then we set it to true. which means that the values were different and the types were the same. Oh, the values were different, but they're both .type. And we didn't find a reason to quit out. Which means that all of these things rang true. And also, it was not, it was any stuff. Because if it wasn't anything to do with these any values, then we would quit out here. So in this case, we don't need to check. We don't need to check children at all. So we can do like this and do all of our children checks in here. Yeah. So we ignore the children checks in that case. So it feels a little bit hacky, but okay. So we're example line 45. And we're saying wrong number of arguments, which is correct, because I changed that. Now I want a string. So we can do source.raw and source.length. And we can do the same thing. Oh no, maybe that's the only place to do it. So we can take that out and that out. I think we're still going to get an error here. Okay. It's at 146. GeoShader source is expecting a pointer to a C string. Okay, I mean, we could do untyped here because this is a C string is just a pointer. So, and this is just a pointer. So, oh, but it needs to be a pointer to it. Okay, let's keep it where we were. And that's why we need the two parameters. We could at some point clean that up, I think, and make that better, but we're not going to do that right now. So then these need to be C strings. I'm kind of surprised. There should be some, maybe we do need to add some type checking, because when we do this, this is just going to be an any string. So then when we come here, it should be like, hey, you can't, at least when we come here, it should say, no, this needs to be a pointer to a C string. I'm also kind of surprised that compile shader needs, oh no, it doesn't take a pointer, it converts it to a pointer. So I mean, if we went like this, it should work. No, okay. Let's have a look. Failed to generate primary. Because the type node. It's any string. So we never upgraded from any string. At what point are we generating? What are we generating here? Well, this is the declaration, right, of the string. And it's still an any string. So we never upgraded, even though we have C string here. So that should have upgraded it. And if we go node value, we see what string it is. It's Bangalang. Oh, okay. It's Bangalang. So it's actually here. We have an any string, but it should have got upgraded to a C string, right? C string is what it's expecting. And our type coercion, when it found an any string, it should have taken the other one. So it should have taken the C string. I'm a bit confused about why that's happening. The just one more thing is always the thing that takes forever, isn't it? So if we have a string literal here, then in type checking, this is where this happens. So nmap? What? That's very confusing. Why do we have a string that is mmap? We're not doing one of those or things, we're doing a right-hand side expression. And we've come across a string node. Oh no, it's this it's this bit here, /n. Okay, that's the new line. All right. But this is the one that caused trouble because the new line one is expecting, is expecting a string. And apparently that's okay. It's just when it's expecting a C string that it's not okay, or I don't know. Let's keep going. Session failed, Bangalang. So this is where we have the issue. So if we step out, and then we step out, and we step over, so we have the different types. So any string here, and the expected type is C string. So the coerced type should be C string. C string, okay. So then we upgrade the node to the new type. Oh, we don't have any string in here. That's what it is. Okay. So I think we need to look for anywhere we have any number. Not here. What is this? Yeah, that should be. That's probably why it was not complaining that it hadn't figured out the type either. Don't need it here. Okay, that's all good. This is the type checking. So the coercion, so we've figured that out. And the naming, we did put any string in there. Upgrade types. Yeah, this is also an issue that it's not here. And this is only looking through numerical types, so it doesn't need it. And same here. So let's try that. I think that should work better. Probably now it'll be a slice. Yep. Slice of I8, which is what a string actually is. So I would like to be able to say like that this is a string and not any old slice of I8. Or it's Well, I'm not sure actually. Maybe it is nice that it's that interoperable. It's a decision to make at some point. So now that's saying it's a slice of I8. Okay, interesting. 2199. Because the C string, if we go to generation, and we look at where we generate our C strings, here they are. See, we cut off the first character because the literals used to have a C at the start. Now they do not, so we do not need to do that. Here we go, Bangalang in the title. Everything's working fine. Cool. So then another thing that I wanted to like kind of do is if I do this, this should take the type string. Could not determine type. See, I want it to default. I don't want to have to put colon string here every time I do a string. It should be the default. If I explicitly want a C string, that's fine. So how do we achieve that? So I guess that's the case where we would it be type coercion? No, not type coercion. Maybe, I'm not sure if this is the right place, but maybe when we go to type check our expression, right-hand side expression, if we coerce our type node, and we find that it's any string still, then maybe we should change it to string. Could it be an upgrade types? Like, if both of these types are any string, then we upgrade to string. Does it make sense to put it in there? Or up here? Let's put it in here. I'm really not sure if this is a good idea, but this is what we're going to do. So if the new and old are both any string, then we're going to, we don't have the context. Type checking context. We'll update it to the string. So this should cause some issues, but hopefully we have access to the context everywhere where we need it. I believe we do. Okay. Does that work? Okay. That's what I would expect. Now it's complaining at line 46. Would be nice if it said this is what we're talking about. But yeah, it's saying I wanted a C string, but I got a slice of I8s, which is a string. So let's give it a C string. There we go. All right. Okay. Whew. yeah, I'm pretty happy with that. I think I'm still a little bit like, because this is really a string, I would like it if this said string, I think. I think that would be more user-friendly than just like happening to know that a string is a slice of I8s. I think that would be better. So I think we need some sort of better support for type aliases. Okay. But I think that's enough for today. Thanks for stopping by. Have a good one. Ciao for now.